there's been a lot of energy and a lot of talk about this reduced bandwidth, this RBTV stuff in the last, well, believe it or not, it came out, it was the copy at the end of last year, wasn't it? The December issue, I think, where we really got excited about this. And to some extent, I felt it would be worthwhile. We're going to spend most of this afternoon talking about it. But what this session is to try and really just set the scene. I've got 15 minutes just to really try and set the scene and explain to everybody, you know, what is this RBTV that we're all getting very excited about. So from October 2014, UK amateurs gained access to the 146 to 147 meg. We've also got access to the extra 1 meg at 70 megs as well. However, Ofcom specifically said, we don't want more of the same. We don't want more FM in there. We want something different. They also, unfortunately, slapped a 25 watts ERP limit on it, which has made life very hard for some of us. And because of the work we've done with the RSGB, they were quite happy to allocate that middle 500 kilohertz for data modes, including reduced bandwidth television or reduced bandwidth digital TV. But there wasn't enough room for our normal 2 megahertz. So we really had to do something different. And Jean-Pierre over in France had already been investigating what happens if we can get down below 1 megasymbol or 1 megahertz in bandwidth. You know, the difference that it really makes to what you can do DX-wise. And so the natural thing was for us to start to look at it. And if you remember, 2 years ago, Charles, when we were at Finningley, talked about could we do some narrow band digital television. And then last year at CAT15 in Basingstoke, Brian came up with the Raspberry Pi idea of could we use that as a body or a vehicle to really try and drop the bandwidth of what we're doing. So what is it? Well, it is actually normal fast scan digital television, but I think for definition's sake, RBTV we're saying is below 1 megahertz wide or 1 megasymbol rate per second rate. The agreed standard that we've come up with, mainly because of the design work that Brian's done, is 330 kilosymbols, and that gives us about 450 kilohertz wide. Now the guys in Luton have done something else. I know Ian KDD is running slightly higher than that. So there's nothing to say you can't run higher, but for the purposes of this talk, really, we're talking about the work that's been done around 330 kilosymbols. Now, it's still based on the DVB satellite specification, which is what we use at 23 centimeters. It's what we run on 437, but we run 2 megahertz or 4 megahertz. The standard is still the same, but because we've dropped the bit rate so low, MPEG-2 really doesn't look very nice. The video coding MPEG-2, when you get down to these levels, looks pretty ugly. And the work that Brian's done and we saw in Basingstoke was that MPEG-4 is actually still looking okay for amateur type purposes, even down at these bit rates. The other problem we've got is that normal satellite receivers won't work below 1 megasymbol or 1 megahertz. They have not been designed. The DVB spec is 1.5 megasymbols, so they can't be expected to work that low. It's just pure chance if we find one where the implementation is good and it does work lower than 1.5. So we needed to do something different, but we needed to address a couple of specific technology areas. And if you look at a typical transmission chain for digital, You've got all the video bits, you've got the capture and the compression, you've got the converting it into a transport stream and producing the INQ data, and then putting it into a QPSK modulator and potentially a linear amplifier. So it's around this area, the video compression area, that we had to look, because what we've said is we're going to leave the rest of this pretty much the same in the transmitter. On the receiver we need to do something to decode it, but in the transmission it's just the video compression that we needed to look at. And as I said, Brian's already done it, had a look at why we should use MPEG-4, and you may remember these videos that he showed in Basingstoke of this is 460 kilobits MPEG-4, and it's at 352 by 288, and I think most of us commented that in Basingstoke that actually, yeah, we'd work that in a contest, no question. You know, you could certainly, for amateur purposes, that would certainly do in a DX mode. I mean, some people can even say they can see the compression artifacts, don't they, Brian?
Yes, it's only slightly obvious.
So that's the type of picture quality we're talking about at 330 kilosymbols. Recorded on a Raspberry Pi? Yeah, Raspberry Pi. There we are, look. Told you could work it. Rob and I had used that, wouldn't we, Rob? So the game is to say, right, so what can we do? How can we get this MPEG-4 stuff? And really there are three solutions. One is, as you've just seen, the Raspberry Pi with its inbuilt MPEG-4 encoder. Bit of a downside, you can't do an external video input yet, but you can play pre-recorded transport stream files. You've got the Linux-based solutions, which Rob and Charles are very happy doing, but for the most of us, I'm afraid we regard it as a little bit geeky. It sounds a bit too much like hard work. As I say, it's radio, not computing as far as I'm concerned. And you can run PCs running FFmpeg. That whole area is quite similar, whether it's PC or Linux based. So the only really practical solution, certainly to begin with, although we think that there will be more and more MPEG-4 embedded encoders coming along, at the moment the only practical solution really was a Raspberry Pi. As far as the modulator goes, it is standard DVB-S. We're not doing anything magic. We're just running it at a lower symbol rate. And so we've got a couple of choices. The DATV Express, brilliant card, still available from the shop, and absolutely the most flexible solution possible. Wide range of symbol rates. Can't remember what the top is, but certainly it goes down and does the symbol rates we're talking about. And 70 megs to 2.5 gigahertz at a reasonable output level. So, you know, a very, very, very flexible solution. Brian had come up with his Raspberry Pi plug-in card that we'll hear a lot more about today. That's a low symbol rate modulator, and it's fixed. It's a fixed symbol rate. And you can put a small local oscillator in there to make it go 50 megs up to 1.3 gigs. And dear old Lawrence, not to be left out, has come along and they've done modifications on the DTX1. That will run at low symbol rates and will go from 146, so it will now cover the 2 meter band, up to 2 gigahertz, but still needs an external MPEG-4 encoder. And so if we were to put those lumps together, this is what it looks like. A Raspberry Pi, a standard Raspberry Pi, Brian's board. This bit here is the bit that we all want to forget about, but we really, really can't. You've got to have proper filtering on this stuff. And then power amplifiers. That's the design that Rob published. Works really, really well, but it does need screening. It hoots like a good one if you build it like that, as I found out. So, you know, it really is not difficult to get on. If you want to go down the DTX route, which is the most flexible, the MPEG-4 encoder, which is the Raspberry Pi, into your standard DTX1 with a transport stream board fitted, There again, you need one of these. You know, if you look at the DTX1 instructions, it absolutely says you need filtering and into the similar sort of power amplifiers. And that will get you up to the legal limit. You will be able to run 25 watts ERP using that sort of setup. Now, the receiver is the hard part, which is bizarre. And that's because the chips don't go below 1 megasymbol. And so, dear old Jean-Pierre has done a lot of work on this, and based around his to-tune software and some very specific hardware, he has come up with a solution that will work from right down at 100 kilohertz right up to 45 megasymbols. So you can use the to-tune solution for normal digital television, for reduced bandwidth, and also for watching satellite. You know, it really is a very, very good solution. It's going to outperform any other received solution for digital television, for amateur television. And it's still being developed. Jean-Pierre was telling us he's got ideas about how he can do to improve the performance still. The only problem that we've still got really is the need to convert 146 megahertz to L-band. We kind of fix that. So this is what a typical receiver looks like. I even included an aerial on this one, and a preamp. Oh, and a filter. Yes, you need those on receive as well. In some respects, the filtering is quite challenging because you're, particularly if you live near an APRS base station or a repeater or whatever, you know, they're big signals and they're not far away. Into an L-band up converter, into a mini tuner, and that runs into a PC which is running the to-tune software. And that's your receive system. And yes, it is PC based, but with some of the smaller PC solutions that you'll see in the demo area, it really doesn't look like a PC anymore. So what is the 146 meg receive problem? L-band is 950 to 2150. Standard tuners cover this band. For 437 megahertz, which isn't in there, we use this thing called the SUP2400, and that's got an oscillator running at 2400 minus 437 gives us an output at 1963. So for 5-6 quid from the BATC shop and a little bit of soldering, you can receive 70 centimeters on an L-band receiver. The problem comes with 146 megahertz. If you do the same sums, this number ends up at 2254, and that doesn't fall within L-band. And so we either need a different receive conversion, a receiver converter, L-band converter design, or a tuner that covers 2254. And there is a potential that we'll be buying some tuners which will cover from 950 up to 2600. So if that is the case, it's potential that we can use the SUP to do 2 meters as well as 70 sems. But
tuner module?
Yeah, the tuner module. Yeah.
So are they compatible with
Yeah, they will drop in on the design. Yeah. So keep your eyes peeled. So why all the fuss? Well, this reduced bandwidth stuff goes really, really well. You reduce the bandwidth, you get gain. And the more you reduce the bandwidth, the higher gain you get, and the further it goes. F9ZG does tests over a 200 kilometre plus path back to Paris with a high success rate. They've discovered that actually 250 kilosymbols isn't low enough. Jean-Pierre was telling us last night, then was it 125 kilosymbols? Yes. Yes. And the success rate is even higher at 125 kilosymbols. I hate to say this, but Terry and Rob worked 117 kilometres on 146 with 25 watts ERP. That was using the Digital Express transmission and to tune receive. and I've worked Arthur G4 CPE over in Luton, 95 kilometres on a Raspberry Pi solution. So it really does work. And the great thing about it is as well, is being 2 metres, any newcomers to the hobby are likely to have got an aerial, and it doesn't matter that they're using RG213, and you know, it's just easier to get going on 2 metres than it is 1296. You know, it's you know, it's actually a great demo for clubs. This here is a Raspberry Pi with a DigiThin, and I take it around to local radio clubs, and that is a digital transmitter, and it sits there and it works, and you just have a receiver, which is the mini tuner, and that's all, and that's a great demo to show to people. And there is just one more thing I must show. I think it's here, isn't it? Yes. So they've just announced, or on the forum, actually it must be somewhere else, but there's also somebody who's invented a keypad, so you no longer have to take your HDMI monitor out with you when you're portable. So that really is an overview of what RBTV is all about, why we're getting excited, and the steps to get there. And what we're going to be doing this afternoon is spending a bit more time expanding each one of those steps. But in the December CAT15, we announced that actually to try and encourage and push this, and it certainly did the trick, we said we would announce some awards, and we did some operating awards, 3 operating awards, and we also said that we will give one of our grants. If you remember, the committee has got the ability to be able to say, these guys have really put some effort into helping amateur television move forward, and we can give, you know, some awards purely for development rather than operating. And so, great pleasure this afternoon to be able to say, you know, this has really moved forward in the last 9 months, big time. And we think there's some guys in the room who really do need recognition of what they've done. We envisaged we were going to present 3 trophies. But actually, we're only going to present 2 trophies because the same guys did 10 kilometres and 100 kilometres. So, Rob and Terry, well done. If you'd like to come forward.
Pleasure to me because I was born just north of York. And these guys are even further north. It's a great pleasure.
I'm just glad I didn't have to do it. It's great stuff. Well done, guys. Well done, it's good. It's good. However, you will notice there is still one category available. We also said 250 kilometres on any band. These were on 146, which is hard because of the ERP limit. No submissions yet for the one over 250 kilometres. Dunkery Beacon to GB3GV is 239 kilometres. We will get there. We'll find a path. Okay, the second part was the more generic. We recognised when we started this that receive was going to be the hard piece. There wasn't a receive solution. We knew somebody had to cook something special to get us the ability to be able to receive this low symbol rate stuff. And so we specifically said for receiver technology development. And we couldn't give one award. We really feel we've got to split it between 3 people, 2 of whom are here today. Jean-Pierre in particular, who did a lot of the basic design work and the software work. Brian, who put a lot of work into the hardware side of it and did the kit work. And dear old KLB. I mean, he has done so much of the beta testing and the prototype work and the publicity of this project that we feel that he deserves recognition as well. So Jean-Pierre, Brian, and Colin, if you're in the ether, would you... Have you got the? Yeah. We're not very well organised. Sorry. There we go. Brian, Jean-Pierre.
Brian, really appreciate all the hard work.
Thank you very much.
Jean-Pierre, merci beaucoup. All really hard work, I think.
And this one is for Colin. I'm not sure if he is on the stream, but if he is, I mean, he's done a fantastic job in helping push the whole thing forward. So we'll make sure he gets this as well. Thank you very much, guys. Okay, and that's it. That's the end of the introduction. And Brian, are you on next? I think.